Hi, how is it going? Welcome to Code with Z. Today's problem is LeetCode number 2, adding two numbers, and the numbers are actually inside linked lists and we gotta add them together. Alright, let's solve it together. For solving this problem, we need to understand two things. The first one are the elements that a linked list is made of, which are called nodes. And the second one is summation, which I'm gonna come back to later. Each one of these circles are called a node, and each node has two properties. The first one is a value. The numbers that you see inside the circles are the values of those nodes. So for example, the value of this node is 2, and the value of this node is 4, and the value of this node is 3. Now that we've understood what a node value is, we're gonna go to the next property, which is ironically called next. Every node has a next property, and the next property of this node is the next node. It's self-explanatory. So basically, this means the next of this node is this node. And the next for this node over here is this node. But what is the next property for this node here? Well, you see, if we actually draw this, there's nothing here. There's literally nothing. Therefore, we're just gonna call the next property null. So the next property of this node is this node because it's pointing to the next node. The next property of this node points to the next one. And the next property of the final node points to null because there's nothing after it. Alright, now that we've understood nodes and the properties they have inside a linked list, let's do the summation of only one linked list. By that I mean we're gonna have a variable called sum, and we'll just add these values to it one by one so that we get the sum of all the values inside our linked list. But how do we actually do this? Well, we need something that would say, I'm pointing at this node and I want the value of the current node. And when we add this value to this variable over here, we want this to move on to the next node and be like, alright, it's your turn, and add the value of this one as well to sum. And we want this to move on to the next node and add the value of this node to sum as well. This thing over here is called a pointer. We usually give it a name like current, so we keep track of which node we're currently pointing to. So when the problem gives us a linked list, for example L2, we're gonna assign our current variable to that linked list. This over here is like saying what we have here. We're saying we want the current variable to point to the head of our linked list. By doing this, we can access the properties. For example, I could say current.val, and that's gonna give me the 2, and I could also say current.next, and that would give me the next node to my current node, which is this node over here. Now imagine we have our sum variable initialized to 0, and our current variable is pointing to the head of our linked list. We could have a loop over here and say sum is equal to current.value plus sum itself. So this will give us the values inside these circles, and this is to make sure that we add up the previous values of sum. So this actually does the summation, right? But it's gonna do it for only one node. If you remember, we need to actually move to the next node and add the values of that one as well, and then so on and so forth. So let's add the code for doing this as well. As you know, the second property of our nodes here is the next property. So we're gonna use that. We're gonna say current is equal to current.next. This means our current pointer over here is equal to its next, and its next is this node over here. And this is how we actually move to the next node. We assign current to its next. So if we trace this, it's gonna be like add this 2 to the sum and then move on to the next one. Add this 4 to the sum and then move on to the next one. Finally, add this 3 to the sum. But if I'm being honest with you, adding the values of two linked lists together is actually pretty similar. We again have a sum. We're not gonna add 2 and 5 together and then add them to sum. We actually do it separately. So we add 2 to sum and then we add 5 to sum, and that's it. Let's call this one L1 and this one L2. So linked list number 1 and linked list number 2. And we wanna add them together. So in our code, we obviously have a sum that's assigned to 0 in the beginning. We have linked list number 1 and we have linked list number 2, and we also have a loop. Inside of our loop, we're gonna say sum is equal to L1 dot value plus sum itself. This is like saying, so this node over here, which is L1, we want its value to be added to sum. So instead of using the current variable over here, we use the linked list itself, because even if we've said current is equal to L1, it's gonna be the same thing because we're using L1 and we're saying current is L1. So we're just using L1 instead of current. So when this 2 has been added to sum, we're gonna say L1 is equal to L1 dot next. And this will literally do this. It's gonna move on to the next node. And we're gonna literally repeat these two lines for L2. So again, we're gonna say sum is equal to L2, repeat with me, dot val plus sum, and that's equivalent to saying this, L2. So we're adding the value of this node to sum, and then we're gonna assign L2 itself to the next node. And this is gonna move these to the next one. The tiny small thing that we still need to understand is that when we add, for example, 2 and 5, it's gonna give us 7, and then we're gonna add 7 to sum. But when we add 4 and 6, it's gonna give us 10. And this one over here needs to be added to the next one. Because as you remember, if we had 15 plus 6, for example, we would say 5 plus 6 is 11. We write down this digit and then carry the next one. And we're gonna say it's gonna be 21. Therefore, when we are defining our variables, we need to define a carry. You see in our code over here, at the end, we're gonna generate a node for our solution. So for example, 2 plus 5 is 7. At the end, we're gonna generate a node with the value of 7. How are we gonna generate this, you might ask? Well, the question provides us with a class that we can use. The only thing we need to do is to give it the value. For example, for this, we're just gonna say list node, and we just give it the value of 7. And that will generate a node for us. So we don't have to worry about this part. But what actually matters here is that when we add, for example, 4 and 6, it's gonna be 10. And we only want the first digit over here because each one of these only hold one digit. And we want the 1 to be added to the next summation. As you can see, we had a 10 over here. And we literally said, here's the 0. And we're gonna carry the 1 to the next summation. We're gonna say sum is equal to carry. Because at the end of each iteration of our loop, the first digit of our sum is gonna be turned into a node, and whatever is left is gonna be added to the next summation. So in the next iteration, we want our sum to be equal to carry. Because as you can see, the one that we added here is added to the next summation. Therefore, in this part of our code, we always need to make sure sum is always equal to the first digit of the summation, and carry is equal to the second digit. And how we do this here is pretty simple. I'll just show you in the code. What actually matters is this part of the code that you understand adding two linked lists together is equivalent to adding the values of one linked list and repeating it for the next one. Like as you can see, these codes are literally identical besides the L1s and the L2s over here. We're gonna jump into the code in a bit, but I want you to understand that what we return here is a linked list that slowly builds up. In the beginning, we only have a node and then 2 nodes and then 3. But for starting the process, we need a node to start with, a dummy node that we're not gonna care about. This is gonna be our dummy node that we're just gonna use as a reference for the next nodes that we build. And you might ask, why do we even need a dummy node? Well, let me give you an example. Let's say we are at the end of our calculation. This turned out to be 7. This one is 2, for example. And this one is 5, right? We're at the end of our calculations, and these nodes are actually linked together. So we've created a linked list. There's a problem with this. At the end of our loop, we're pointing to our last node in our result. And if we return this, we're just gonna return the last node because we don't have any references for the previous ones. Therefore, we need a reference that we can add to throughout the loop, like so. And when we finish and break out of our loop, we can just say, return the next of our reference, which is gonna be our dummy node. And the next of our reference is gonna be our answer. Alright, so in our code, we're gonna define our carry, which is gonna be equal to 0, because in the beginning, carry is 0. Then we're gonna define our dummy node as an empty node. And this is given to us by the question itself. Next, we're gonna define a current variable and we assign it to our dummy node. You're gonna see why in a bit. Don't worry, I'll explain the code to you at the end as well. Now, for our loop, we're gonna say, while L1 is not equal to null or L2 is not equal to null, do the following. This will make sure that we keep looping as long as one of these nodes are valid, so they're not both nulls. We're gonna assign our sum to carry because carry in the beginning is 0, so it's like saying sum is equal to 0. And then for the next iterations, as you remember, when we said 4 plus 6 is 10, we add the 0 here and then we carry the 1 to the next one. That means carry is gonna be added to the sum for the next iterations. But in the beginning, it's like saying sum is equal to 0. Then we're gonna say if L1, meaning if L1 exists, add its value to sum. and then L1 is gonna be equal to L1 dot next. This will make our L1 pointer move to the next one. So we're gonna go from 2 to 4. And then we're gonna literally do the same thing for our L2. So if L2 exists, add its value to sum, and then L2 is gonna be L2 dot next. Now that our sum is updated with the values of L1 and L2, we need to make a new node and only add the first digit of that sum to this one. For example, if this was 17, we only need the 7 here, not the 1. For that, we're gonna use the mod operator. This line literally says, if the current sum is 17, I only need the first digit, which is 7. And this will give us the 7. Or if it is 56, it will just give us the 6. So what will happen to this one over here? Easy, we're gonna assign that to our carry. We're gonna say, carry is equal to sum divided by 10. This means if our sum is equal to 50 and we divide it by 10, we're gonna get 5. And this is our carry that's gonna move on to the next one. For example here, 4 plus 6 is 10. We keep the 0 and carry the 1 to the next summation. But what if we have 56? If we divide that by 10, we're gonna get 5.6. And we only want this 5 as our carry. For solving this, we're gonna say math.floor and we're gonna wrap it around our calculation. This will make sure if we have something like this, it will only return this digit because it's gonna give us the floor for this range. And then our current.next is gonna be equal to a new list node with the value of sum. And my apologies, I forgot to add a new here. This is literally what we said. Our dummy head is gonna be in the beginning, and then the sum that we've calculated is gonna be added to the next node. And at the end, we're just gonna return anything that's after our dummy node. So let's update our current as well. So current is equal to current.next. So we made the next node here, and we moved our pointer to the node we just made. This will do all the calculation until we get out of the loop. And when we do, imagine if this was 7. 7 plus 4 is 11. So we have 1 and we have another carry. So we gotta put this 1 somewhere. Therefore, we gotta make sure if after our loop, our carry is greater than 0, we're gonna repeat what we had here, as you can see. But this time, we're gonna add the carry because as you saw here, if this was 7 and this was 4, this would be a 1 and the next one is just gonna be a carry and there's nothing to add with it. So we're just gonna assign the value of our next node to the carry. And at the end, we're gonna return our dummy node dot next. So we're gonna return everything after our dummy node. So let's test this. As you can see, we've passed all the tests. And let's submit it. And voila, we beat 78% of the other submissions. That's awesome. Thank you for watching and make sure to like and subscribe. Catch you in the next one.